Welcome to the deep dive.
Mm.
You gave us your knowledge stack, your research, your notes, your articles on organizational modeling and workflow.
And our job is to synthesize all of that into the most potent, universally applicable insights.
Today, we are really diving into the architecture of business itself.
Yeah, and we're not talking about code or balance sheets here. We're talking about the fundamental logic, the rules that dictate how an organization actually takes in inputs and delivers value.
That's right. And while the source material you shared with us uses some pretty rigorous industry frameworks for business process modeling, our mission today goes way beyond just definitions. We're trying to extract the core truths about how you can diagnose those really deep-seated inefficiencies, how organizations respond to the outside world, and maybe most importantly, how to manage large-scale change without, causing a total disaster.
Think of this deep dive as a masterclass in seeing the gears turning inside any business. We'll be navigating, I think, three major themes that really emerge from your material. First, establishing the context of the enterprise. Second, the actual tools for modeling and understanding the internal flow of work. And then finally, diagnosing problems and managing the risk of change.
Okay, let's unpack that. Let's start with context. I mean, to really map out an organization, you have to define the boundaries first, right? Who are we dependent on? What forces are we just reacting to?
Precisely. If we get the organizational context wrong, every single process model we create after that is going to be, fundamentally flawed. You have to be absolutely clear about who's inside the model and who's outside.
Let's use a great real-world example from the sources.
Right.
A major hospital. They provide health care, but they rely so heavily on these external entities.
Sure, pharma companies, tech firms.
Right, for drugs, for specialized equipment. When you're drawing up the organization model for that hospital, how should you formally represent those companies?
They have to be categorized as suppliers. It's a formal designation.
Okay, so why is that technical term supplier so important? Why not just call them partners or, lump them into the general environment category?
It's all about the nature of the relationship. Suppliers are external, yes, but they provide essential inputs.
The things you need to operate.
Exactly. Raw material, products, services. If those suppliers fail, the hospital's ability to function it fails. They are active, managed dependencies. You have to model them explicitly so you can measure their performance and manage that risk.
So they're the critical input link. If the hospital is dependent on them for the mission, they have to be named.
That's it. They are fundamentally different from customers who get the value or from some other entity that just, influences strategy from afar.
And that brings us to the second point on context.
Okay.
Let's widen the lens a bit. Your sources gave the example of a soft drinks company facing this huge consumer shift. People are moving away from sugary sodas and towards sparkling water.
A massive trend.
Right. And the company can't stop it, but it totally dictates their product strategy for the next decade. Where does a shift like that fit on the organization model?
That trend is a classic factor in the external environment.
I find that fascinating because it completely flips the dynamic we just talked about.
How so?
Well, with suppliers, the relationship is transactional, it's manageable. With a consumer trend like this, it feels purely reactive.
That's the key distinction. Factors in the external environment market trends, new regulations, demographic shifts, these are things the organization has to monitor constantly and react to strategically. They influence your decisions, but you can't sign a contract with a market trend.
You can't manage its performance.
Exactly. You can manage a supplier's input. You can only adapt to the pressure from an external factor. It's the ultimate reality check for your long-term plans.
Okay, so we've mapped the outside world. Now let's transition into the actual internal mechanics. How does that external pressure translate into day-to-day work, and how do we model that work?
This is where we shift from the big organizational map to the detailed process map. If context tells us who is involved, the process map tells us how the work actually gets done.
And one of the most powerful tools for this is the event response perspective. Let's picture a model showing a customer order flowing across three departments: sales, warehouse, and shipping. What's the main benefit of looking at it through that event response lens?
The primary benefit is that it focuses on the end-to-end flow of work to deliver value to the customer.
So why is that focus on the end-to-end flow so critical? Isn't it just easier to model things by following the org chart? Sales does sales tasks, warehouse does warehouse tasks.
It might seem easier at first, but the org chart view is really the foundation of internal silos. It encourages departments to optimize their own little worlds, often at the expense of the overall customer experience.
Right.
The event response view, it forces cross-functional accountability. An event like order received, it triggers a sequence of tasks that jump between departments. It prioritizes the outcome, the customer getting their stuff.
So everyone sees themselves as part of a single value stream, not just a siloed unit.
Yes, that's the goal.
That leads directly to one of the most common mistakes I see in process improvement, which is skipping that diagnostic phase.
Oh, absolutely.
The sources gave that example of an insurance company planning a major claims overhaul. The sponsor is keen to just skip documenting their current inefficient manual process, the as-is model, and jump straight to designing the automated to-be solution.
Classic mistake.
So why is building that as-is model first such a non-negotiable step?
Because you simply cannot build a solution until you have correctly identified the problem. The whole purpose of the as-is model is to identify the specific problems and root causes that need to be fixed.
I've seen organizations do this. They rush to a solution because everyone knows the current process is terrible. But if you skip the as-is, what's the real danger?
The danger is that you just automate the misery.
Right.
I mean, we've all seen it. You try to fix a process only to find you've just automated an absurdity. If the current process is slow because people are manually entering the same data into 3 different systems, and you build a new digital form that still requires 3 separate database entries behind the scenes, you haven't solved anything.
You've just made the waste faster.
You've just made the waste faster. True improvement, it hinges on understanding why the current process hurts.
Then understanding that pain means getting really granular. Let's talk about task components. Say we're mapping a task on a banking website, and that task is determine loan eligibility. What are the specific inputs needed for that task?
Okay, so the inputs are the specific data points that have to be consumed for the task to run. In this case, the system needs the customer's income, their employment status, and the loan amount.
Wait, why not the interest rate? Isn't that needed to figure out the final loan terms?
That's a common point of confusion, and it shows why the definition has to be precise. The interest rate is a resource or a business rule that the task uses. It's based on the bank's policy.
It's not raw data provided by the customer.
Exactly. It's not something the task consumes. The inputs are just the raw materials, the specific bits of information that let the calculation begin. We have to keep those definitions clean. Inputs are data. Policies and software are resources.
That kind of clarity is essential, especially when different teams are all working on the same process. And speaking of clarity, let's talk about communication across a big organization. Imagine a global manufacturing firm. Facilities in Asia, Europe, the Americas, they need a single, unified, graphical way to document workflows, maybe using something like BPMN. What is the main benefit of implementing that kind of standard notation?
The main benefit, hands down, is guaranteed consistency. It provides a common language that is understood by all stakeholders.
Why is a common language so much more important than, say, technical precision in this context?
Because without it, you introduce friction and ambiguity at every single handover point. If every factory uses its own bespoke symbols and labels, every audit, every improvement project, it all requires constant translation and reinterpretation.
It slows everything down.
Terribly. A standardized notation like BPMN ensures that when the analyst in Germany sees a specific gateway symbol, they know exactly what that means, just like the process owner in China does. It reduces the cost of ambiguity. It makes communication scalable.
All right, that wraps up how we model the work. Now we shift into the final critical phase, identifying performance issues and managing the risk that comes with big organizational changes.
Right. Once you have a clear map of the process, you can immediately start seeing where the flow is compromised.
Let's talk diagnosis using that theme park example from the sources. It's peak season. The park has plenty of staff selling tickets, lots of kiosks, no problem there.
Right.
But there's only one single old security scanner at the main entrance. And it causes this massive queue, backing everyone up. What specific performance issue does that one scanner represent?
That single piece of equipment, the one thing limiting the entire system's throughput, is a bottleneck.
It's the constraint that limits the whole flow, isn't it? It just proves that adding more capacity upstream, like doubling the ticket sales staff, is a complete waste of money if the bottleneck isn't fixed first.
Absolutely. A bottleneck is a capacity constraint that dictates the maximum output of the entire system. It doesn't matter how fast sales is. It doesn't matter how fast the rides are running inside. If you can only push 1,000 people an hour through that scanner, That's the park's maximum rate, period.
So all your resources have to go there
But
first.
the moment you identify a bottleneck, all your improvement resources have to focus on increasing its capacity. Anything else is literally just pushing more work into a traffic jam.
So once we identify the bottleneck, we need a framework to find the root cause. This is where the POPT model comes in. People, organization, information, and technology.
A great tool.
So another scenario,
Hmm.
a customer service delay. Staff are wasting hours manually copying data from 3 separate legacy systems into a spreadsheet before they can process a claim. Which POPT element is the primary cause of that delay?
That is fundamentally a technology issue.
Hold on. The delay is caused by the people doing the manual copying. Why isn't this a people or organization problem?
Because you have to distinguish between the symptom and the root cause. The manual copying is the symptom of the delay, but the root cause is the system architecture, the lack of integration between those 3 legacy systems.
Okay.
The technology is failing to support an efficient flow of information. You could train the people to copy faster, but you haven't solved the problem. You have to fix the structural technological disconnect.
That is a vital distinction. Now, technology fixes are often the riskiest part. Let's move to managing that risk during implementation. We have a high-stakes scenario. A law firm migrating its whole case management system to the cloud.
High stakes indeed.
They have dozens of active high-profile court cases. They absolutely cannot afford downtime or data loss. Which implementation approach minimizes their operational risk?
For any critical system where continuity and data integrity are non-negotiable, the only real answer is parallel running.
Explain that safety net. What does parallel running really provide in a situation like that?
Parallel running means you run the old, proven system right alongside the new cloud system for a set period. You process all transactions on both simultaneously. Yes, it's resource intensive. You're paying for 2 systems and doing double the work.
Right.
But if that new cloud platform crashes, or if the data migration turns out to be flawed, the firm can instantly fall back to the old test system without losing a single piece of critical case data. For organizations where risk avoidance trumps cost, it's the gold standard.
And finally, during these transitions, you always hit unexpected problems. The sources gave an example of a logistics company implementing a new routing system and migrating historical data. What kind of situation doing that migration is an exceptional condition that the plan has to address?
So an exceptional condition is a non-normal event that needs a specific designed intervention. In data migration, the key exceptional condition you have to plan for is when errors identified in the migrated historical data can be resolved.
So finding errors isn't the normal path, but the process for fixing them has to be part of the plan.
Precisely. If your process just assumed all the data would be clean, you wouldn't need a plan for data scrubbing. But finding corrupted or incomplete data is an exception to that happy path. The transition plan has to clearly define the tasks, the people, and the timeline needed to clean that data before the new system goes live.
Otherwise, you're just contaminating your new system with old problems.
And that's often how these projects fail.
So what does this all mean for you, the listener, taking this knowledge forward?
We've established that these process models, they aren't just diagrams, they are the business itself. They're the DNA of how you deliver value. And the biggest risk in any major change isn't a technical failure. It's the failure to accurately diagnose the problem you're trying to solve in the first place. This leaves you with one final provocative thought. If you were to give your organization's process map to a complete outsider today, could they instantly and correctly diagnose the single biggest constraint limiting your throughput? Because if your model isn't clear enough to reveal your greatest weakness, then the process of improvement hasn't truly begun.
A powerful call to action. Thank you for joining us for the deep dive. We'll see you next time.